Here we go. This is a summary of HPC so far. If you are given an equation with an x and a y, the first thing you should do is build a table. Okay, this allows you to evaluate. It allows you to make a graph. You can then use that graph to determine limits and end behavior. And it doesn't require memorization. Most important, it doesn't require memorization. Okay, please remember that domain is from wall to wall, side to side. If there's double arrows, my domain will be, what will it be? All real numbers, so negative infinity to infinity. If there's an endpoint and an arrow, then you'll have an endpoint to infinity, or it could be negative infinity to an endpoint. Yes? Okay, range is floor to ceiling. Okay, that's how range runs, floor to ceiling. So your lowest point to your highest point. Again, if one arrow is pointing to the sky and one arrow is pointing to the ground, it will be all real numbers. Excellent. Boundedness. If I know the absolute min, it is bounded below. If I know the absolute max, it's bounded above. If I know the absolute min and the absolute max, it is bounded both. And if I don't have either, I only have local max and mins, it is neither. It is not bounded at all. So something that has an arrow pointing up and an arrow pointing down would not be bounded. If both of my arrows were pointing up, it would be bounded. If I had a parabola on both arrows, it would be below. And if two arrows are pointing to the ground, it would be bounded above. The only way to have it bounded both is I cannot have arrows. I have to have two true endpoints. Does that make sense? Oh, that's not necessarily true. Sorry, there's one example. Sine and cosine have a true min and max, but it still has arrows because it keeps going on and on sideways. What did I say for neither? What did I say? Somebody else. What did I say for neither? So if I have a function like this, for instance, x cubed, that looks like this if you look at my arms. So something like this, it's pointing up and pointing down. I don't know the absolute max or the absolute min, so this would be neither. It's not bounded at all. Cool? Okay. Anyone need more time on this screen? Or more time? Okay, so let me pause for a second while you copy. Okay, so moving on. And this is the most. The next slide has less things. Okay. So this is in radical form. Remember that the root is on the little arm of the radical. The power is inside. So to go from radical form to exponential, you have a base to the power of a root. If my variable is in the denominator, my exponent becomes what? Negative. Okay? Now, some other pieces that go with this. We use this power functions with inverse variation. Please remember that a power function follows the form k x to the p. K is my constant. Okay? So we focused on inversely. Inversely, k equals, sorry, undo. Y equals, if it's inverse, they're in opposite locations, so the x goes here, so k goes there. This is inversely. Directly, it'd be y equals k times x, okay? Which is the normal form. So this is direct, indirect, okay? So then you would have to transform it, and given an x and a y, you can figure out what the constant is to write the equation of a power function. Yes? That's what we spent last week doing, okay? And if you need to, you can always go back to that. To me, the most easiest piece that we've learned so far, and it's something to do with logic. You don't really have to write this down. You can jot down small notes if you like. IVT, intermediate value theorem. That means if I have a continuous function, as long as the value is in my domain, it has to exist. So if I told you my domain was from 20 to 52, and I asked you, will the function ever hit 40? The answer is Yes, because that value is inside my domain. So as long as it's a continuous function and the value is part of the domain, it will occur. Good? All right, I will give you a minute on this before I move to the next one. Okay, moving on. All right. Composition of functions. That is simply subbing one function into another. If f of g of x is equal to g of f of x, we say the two are inverses. Now, occasionally they're not inverses if one function has a restriction on its domain. Okay? For instance, if I ask you, if you simplified and you had this, the square root of x squared, well, we talked about this in power functions. If I square something, can it ever be negative? No. So this is controlling it and saying that it's always going to be a positive output because I squared it. If I took it to the fourth power, it was always going to be a positive output. So there's a restriction on one of the domains. So in that case, even though I simplified, let's say I simplified two functions, the composition, and they both ended up being x. At first, I would say inverses, but then you have to be careful and make sure you have to watch the restriction of the domain. Even, odd, or neither, we take the x, every x in the function. So for instance, if I had 2x squared minus x plus 7, I would take every x and I would replace it with negative x, okay? So if I replace it with negative x, if everything keeps the same sign, it's even. If everything changes signs, it is odd. If some change their sign and some keep their sign, it is neither. So, also, if there's a constant, it can only be what two types of function? If there's a constant, it can either be even or neither. It can never, ever be odd. Okay? Yes? It can never switch signs. You need a variable to switch signs. Because it doesn't have a variable, this can never change signs. So the only function that keeps its sign is even or neither. So let's look at this particular example. So I'm going to have 2 times negative x squared minus 1 times negative x plus 7. When I simplify it, negative x squared is x squared, right? So I get 2x squared. Negative 1 times negative x is positive x plus 7. This stayed, this changed signs, right? This one changed signs. Therefore, it is not, it's neither. Now, let's pretend I've given you the equation 2x squared plus 7. So when we look at this, 2 times a negative x squared plus 7 is 2 times x squared plus 7. My new equation equals my original, therefore it is even. Good? Okay. All right. Last one. I didn't put a lot of writing. You're going to help me fill in the writing. Yes?
Can you show an example of like one that would be odd?
One that would be odd? If I had x cubed minus 7x. Okay, so that would be negative x to the third power minus 7 times negative x. Negative x times negative x times negative x is negative x to the third. And then negative 7 times negative x is, positive 7x, because the negative times the negative is positive. Notice, this sign and this sign change. Since everything changed, it's odd. If it has a constant, something that doesn't have a variable is called a constant. If it has a constant, it cannot be odd. Because you need a variable to change signs, because you're substituting in for the variable. Okay? All right, moving on. Discontinuity. Name the 3 types of discontinuity. Jump. Okay, so let's start with this. Okay, let's pretend, for example, Miss Olenek did not give you a graph. I didn't give you a graph. I gave you 2 equations. Okay? And They both have a restriction of 2. One of them's less than 2, one's greater than 2. How would I determine what type of discontinuity it was without a graph? Excellent, okay? Whether or not they meet at the same place. So I would take whatever the restriction value is and I would plug it into both equations. So in this case, the two equations, a jump would be each equation or each function has a different output. Whoops. Output. So if I had 2x plus 3 is one equation and x squared was the other, and I substituted in 2, and one was 5 and one was 10, it would be a jump because my two outputs are different. Yes? Okay. What would it be if the output was the same? What type of discontinuity? It would be removable. Okay? So removable is when each function has the same output because they're going to meet up. Each function, same output. All right, and what's the final type of discontinuity? Infinite. And this is all going to be important because when you go to take calculus, you'll do it this algebraic way. You'll plug it into each of the functions. If they disagree, it's jump. If they agree, it's removable. Infinite is if I break a rule. If one of the functions breaks a rule with the restriction. Okay? So give me an example of a function. What are the two rules? There's 3 rules, but we've only focused on 2. What are those 2 rules? Where I could break a rule. What are the 2 rules? Because it creates an asymptote. Right, so what are the 2 rules that said x can't equal a value? What are the 2 rules we focused on?
X can't be in the denominator.
Right, you can't 0 in the denominator. Okay, could give us an asymptote. What else could give us? And square root of a negative, okay? So those are 2 things that would give us an asymptote. There's 3, and it has to do with log, so when we get to log, we'll discuss it. For right now, we're focused on these 2. And the majority of the time, you focus on those 2. We don't use the log one a lot. Okay? Good? All right, I'll wait a second. Okay? Feeling good? So this is everything you've studied so far. Okay? So we're going to do a quick mini review of factoring because factoring is going to be important for today's skills. So there are 5 different types of factoring that you might come upon, and I'm going to try to keep them as simple as possible. Okay, the first kind is a binomial of perfects. What do I mean by perfects? They're perfect squares. So if I have a binomial, which is 2 pieces, I have 2 terms, and they're each perfect squares, I can do this trick. It is the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. So using that formula, what would this be in factored form? X plus 9, and x. Now, if you said x minus 9, x plus 9, you're still correct. The order doesn't matter, okay? I just start with the positive. Everyone good? Everyone remember seeing this type of factoring? Okay, I'm going to roll through this fairly quickly. Okay, ready for the next one? The next one is binomial, not perfect. Okay, so I'm going to use GCF. What is GCF? What's GCF? Greatest common factor. So what is the biggest number that I can divide 6 and 3 by? 3. So 3 is my GCF. And then in parentheses is my answer to the division. I'm going to divide each of these by 3. So 6x squared divided by 3? 2x squared. minus 1. A-okay? Good? So this is binomial, still two pieces, two terms, but they are not perfect squares. Yes?
So you would put the what you divide by outside of parentheses?
Yes, the GCF always goes out front. Okay? If the GCF does not have a term, then it is not a solution. You don't have to set it equal to 0 to solve, because it's a constant in this case. What is 6 divided by 3? And what's 3 divided by 3? Okay? Good? Next style. Next style is the easy peasy lemon squeezy one, right? So, it has to multiply to C, add to B. Remember A, B, C. So it needs to multiply to 12 and add up to 7. So two numbers that multiply to 12 and add up to 7 are 3 and 4, and I'm happy. Sorry, I forgot to say. Trinomial, lead equal to 1. Okay? So, x plus 3, x plus 4, I am done. I don't have to do any extra work because my lead coefficient is 1. So that is the easiest. Two more styles and we will move on. Okay? All right, the next style is a trinomial, but lead does not equal 1. So we're going to multiply AC, and we're going to add to B. So what is A times C? 12. And what is B? 8. Okay, what are two numbers that multiply to 12 and add up to 8? 2 and 6. X plus 2, x plus 6. But I'm not done. Why am I not done? Because the lead coefficient. So the lead coefficient is going to join my constants. It works for one constant, not the other. Which one does it work for? The 6. So this is going to be x plus 2. Now what happens for the one that it doesn't work? 3 goes to the front, and I get 3x plus 2. Problem done. Easy peasy lemon squeezy. Okay, this is what I tried to review with you week 1. I'm seeing a lot of electronics and a lot of conversation.
The one that's like,
Okay, moving on. The hardest kind. Here we go. Last one. I'm still going to do AC, and I'm still going to look at B. What is A times C? 12. What is B? 8. What are two numbers that multiply to 12 and add up to 8? Great. So I have x plus, oh, I chose the wrong thing. Hold on. That's not a good example. Oh, yes, it is. It is a good example. Sorry, I forgot. So what's the denominator? What am I going to divide my constants by? Oh, my goodness, it doesn't work for either of them. So I'm going to move it to both. So this goes up here, and I have 4x plus 6, and I have 4x plus 2. Oh, my goodness, no good. It's not good because 4 times 4 is not 4. 4x times 4x is not 4x squared. So I need to see. I need to check for my good friend GCF. Is there a GCF here? 2. Remove the 2, and I'm left with 2x plus 3. What's the GCF for this one? 2. Remove the GCF, and I'm left with 2x plus 1. If you don't believe me, do FOIL. Once you do FOIL, it checks out. 2 times 2 is 4. 2 times 1 is 2, 3 times 2 is 6, 2 plus 6 is 8, and 3 times 1 is 3. Because neither one of them could be divided. Because there's a lead coefficient. Mm-hmm. Okay, good. All right, if you will grab your workbooks and please look for this page in your workbook. An asymptote is a line that continually approaches a given curve, but it never actually touches it. An asymptote is represented using a dotted line. Okay, I'm going to come back to this top one in a second. Take a moment and please draw in where you think the asymptote should go for picture 1 and picture 2. Okay, so where did you put your dotted line here? X equals negative 2. Okay, so what type of asymptote do you think that is? It's vertical because it makes a vertical line. Okay, where would you put the asymptote for this one? Number 2. Y equals negative 2. So it is horizontal. Going back to the top. Okay, this line here is vertical. This one, when it's on a diagonal, is called a slant. And I left off a little piece, but this one right here is horizontal. So we have 3 types: horizontal, vertical, and slant. And I have 3 friends that I'm going to introduce you to that will teach you horizontal, vertical, and slant.
Who's that?
My 3 friends are Betsy, Bobs, and Botu. Betsy, Bobs, and Botu. I'll introduce you to them in a second. Betsy, Bobs, and Botu. All right, good. Here we go. All right. Finding the 0 of the denominator will give you the vertical asymptote, unless it is also a 0 at the numerator, and in which case it is a whole. Okay? Give me one moment while you copy that. So my friends are here. Shh. We're going to start with my friend Betsy. Okay? Betsy stands for bottom. Bottom equals top coefficient. And actually it's lead coefficients. Okay? Lead coefficients. Okay? So we have an example right here. Yes? So, what do I mean by bottom equals top? I look at the power. They both have a power of 3. The highest power is equal. So I'm going to use Betsy. So I'm going to focus on the coefficients. So what is the coefficient of the numerator? What is the coefficient of the denominator? 4. So my horizontal asymptote is going to be at 2. Okay? My friends Betsy, Bobs, and Botu help me find the horizontal. The vertical I simply solve for the denominator. Okay? Let's move on to Bob's. Bob's stands for bigger on bottom. If it's bigger on the bottom, what do you think my horizontal asymptote is going to be? 0. You're absolutely correct. Okay, so if I had 7x to the 3rd plus 8 over 9x to the 5th minus 2, and I look at the power is bigger in the bottom. 5 is bigger than 3, therefore my horizontal asymptote would be 0. Y equals 0 would be my horizontal. Good? And the trickiest one of all is my friend BO2. What do you think BO2 stands for? You got the top. You got the top right. On is correct. Bigger. If it's bigger on top, it's undefined. Oh, but if it's undefined, we must check for my good old friend slant using synthetic division. Now, you were taught long division, so you are more than welcome to use long division. I don't like long division. I find it complex and tricky. So I'm going to show you synthetic division before we practice today. Everyone ready?
Yeah.
I love synthetic division. I think it's 10 times easier than long division. How many of you hated long division in Algebra 2? Yeah. All right, so let me give you a new method. So this is the problem, yes?
Yes.
Okay, let me go to a new screen. Read the problem to me again. X minus 3? Okay. Where did those numbers come from?
I don't know.
Yes. This is A, B, C. Because there is no B, it gets a 0. Where did the 3 come from? It always comes from the opposite of the denominator. Ready? First thing we're going to do is drop it like it's hot. Bam. 2. Okay? Then we're going to multiply. 2 times 3 is 6. We're going to add. 0 plus 6 is 6. Okay? The last final this is my remainder. Okay? So, 6 times 3. 6 times 3. 6 times 3. 18. So my remainder is going to be 19. So my final answer is 2x, because I'm going to drop 1x, I'm going to drop a power, plus 6, with a remainder of 19 over x minus 3. Okay? Okay. So we'll take a timeout because somebody told me where 201 is. Can you share with these gentlemen, because they were not paying attention before when you said where 201 came from?
Oh, ABC.
Thank you, ABC. Okay, yes.
Why is B like that?
Because there's nothing there.
All right. So let's try an easier one so that you can see, in fact, the synthetic division works. Let's do x squared plus 7x plus 12. Okay? And we're going to divide it by x plus 4. Yes? Okay, so the first thing I do is start with the opposite of the denominator. The opposite of the denominator is? The opposite of the constant of the denominator. Wow, guys, what is the denominator? X plus 4. What is the constant? 4. What's the opposite of 4? Thank you. I got half awake today. Okay. Yes. Okay, now, what am I going to write inside here? 1, 7, 12, my ABC. Okay? You go in order of power. If any power is missing, you must fill it in with a 0. Okay, so. Drop it like it's hot. What goes? 1. Now I'm going to multiply this by negative 4, and I get 7 plus negative 4 is 3. Times it by 3 times negative 4 is negative 12. My remainder is 0, because there is no remainder, because this is actually factorable. So this translates to x plus 3. Cool? So it works. Okay, let's put it to practice. Turn the page. Turn the page. Okay? So you have the problem that says x over x squared minus 16. I always do horizontal first. I always do horizontal first. So is this my friend Betsy, Bob's, or Botu? Bigger on the bottom. So this is bigger on the bottom, which is my friend Bob's. So my horizontal is y equals 0. Nice job. How do I find the vertical asymptote? How do I find the vertical asymptote? Look back at your notes from a couple seconds ago. How do you find the vertical asymptote? No, that's for horizontal. Vertical asymptote, guys. Top diamond. Zero the denominator, which means I need to solve for the denominator. So in order to solve this, I need to factor it. That's why I reviewed factoring today. So what is this in factored form? X plus 4, x minus 4. What is this as a solution? Negative 4 and what is this? Positive 4. Quick little trick. As long as this is a 1, all you have to do is flip the sign to solve. Okay? So my horizontal asymptote is? My horizontal asymptote is? 0. My vertical asymptote is? 4 and negative 4. Okay? Are there any holes? Read the rule for holes. Somebody read the rule for holes.
Unless it is also 0 on the numerator.
Unless it's also a 0 the numerator. So, is negative 4 or 4 going to make x 0? No. Therefore, for holes, I write none. Don't you dare write 0 because 0 is a value and it'll think that there's a hole at 0. Okay, let's look at number 2. Okay, number 2 says 2x minus 6 over x plus 2. Power of 1, power of 1. Oh, bottom. Describe the bottom and the top. They're equal. So it's coefficient. So what's the coefficient of the numerator? 2. What's the coefficient of the denominator? 1. Lead coefficient. 2 and a 1. What's 2 divided by 2? 2 divided by 1. 2. So y equals 2 is the horizontal asymptote. Yes? Okay. All right. So now we need to solve the bottom. X plus 2 equals 0. X equals? What does x equal?
2.
Negative 2. That is my vertical asymptote. I need to check for holes by factoring the numerator because I have to make sure that this is not a factor of the numerator. So this, remember, is a binomial non-perfect. So I need to use, look back at your notes. This is a binomial non-perfect.
So why don't you just plug in negative 2?
I could, but I want you guys to have practice with factoring. What do I do? Binomial, not perfect. Thank you. Greatest common factor. What's the greatest common factor for 2 and 6? 2. So 2 times x minus 3. Is x minus 3 the same as x plus 2? No. So for holes, it's going to be none. All right. So ladies and gentlemen, 3, 4, 5, 6, same exact page. That is your homework tonight.